So this is page 49 and 50, random sampling. You'll actually be doing random sampling when you go to Ainsdale next year, but you need to know about random sampling when you're investigating diversity. So here we go. So this is a aerial photo of a field, and these white dots here are dandelions in the field, and we're going to try and compare the numbers of dandelions with field 2, which is on the next page. To do this, we could start counting them, but why do we sample? Because the field is too big to count all the dandelions. Presumably this is just a small part of the field. So we need to sort of randomly take samples, and we need some sort of system of choosing places to count. Because if I was just counting on here, I'd probably count where there's lots of dandelions, but that's not fair. So we need to create a grid. This actually suggests creating a 15 centimetre by 15 centimetre grid for this field. And first thing, notice it isn't actually 15 centimetres long. It's only 13, so I can only actually go up to 13 on here. So here we go. So I'm making a grid. If you were doing this out in the field, you'd be doing this with a large tape measure and doing it every metre. But on this photograph, we do it every centimetre. And this way, it's not even 13; it's only 12. So here goes our 12. So whatever area you've got, you just want to divide it up into a grid. So I'm just going to divide this up into a grid. I'm not doing it super exact to try and save time. And let's go across the top. So I'm actually going to just use 12 on this one. So we'll pretty roughly just put my lines on here so you can actually see the grid. If you're out in the field, you wouldn't put any lines on. You'd just do the coordinates, then place your quadrat and count the dandelions in the quadrat. So going across there, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And likewise, I'm going to go across here. This is definitely the most interesting video you've ever seen. Well done if you're still with us. If you fast forwarded it and just paused for the moment, welcome back. Okay. And again, I can just, doesn't matter which way around the numbers go. 7, 8, 9, 10, 11, 12. So we've got X going that way and Y going that way, and we've divided our field up now. So I've used a random number generator just on the computer. You can sort of see it there. Here are your random numbers. You can do these on your calculators, or you can do these on your phones. Just generated random numbers between 1 and 12 in 2 columns, and these are going to be what I'm going to choose. So I'm just going to copy those across. So we've got 2 and 7, 9 and 5, 5 and 10, 11 and 2, 1 and 5, 10 and 2, 7 and 4, 11 and 11, and 9 and 9. We need another one. I'll just generate another one. There we are. 12 and 5. Okay, so those are my random. So I just need to do some counting now. So quadrat number 1, 2, and 7. So this is my quadrat, and there appears to be no dandelions there. 9 and 5, 1, 5 and 10, 2, 11 and 2. We need some sort of rule as well for if dandelions are touching the line, then usually we count the top on the left and don't count the bottom and the right, so I'm not going to count that one. 1 and 5, and 0 for that. 10 and 2, and I'm going to have 1 there. 7 and 4, 1, 11 and 11, 0, 9 and 9, 0, and 12 and 5, 0. Well, that was exciting. I've done this for the other field already. I've put the X and the Y's on, and we just need to do the same. So 2 and 7, 2 and 7, we're going to have 1, 2, 3, 4, 9 and 5, 0, 5 and 10. Does this make you want to feel like you want to be an ecologist? I'm going to go for 2 there because there's 1 right on the line. 11 and 2. 2, 1 and 5. It's suspiciously dark there, however, we're going to have 0. 10 and 2. 1, 2, 3, 4. 7 and 4. 0. 11 and 11. 1, 2, 9 and 9, 0, 10 and 10, 1. We now need to calculate the mean. So we add them up and divide them by 10. So 3, 4, 5. So for field 1, the mean is 5 divided by 10. So that is 0.5. That is dandelions per, on this photo, per centimetre squared. And field 2, mean is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Divided by a number of samples 10 is 1.5 dandelions per centimetre squared. So those are our two means. And you could then go on to calculate your standard deviations and possibly do a t-test on these results, but more on that in the stats package. There is just a little bit left, and field 1 is used by grazing cows, field 2 is hay, Describe the difference in the number of dandelions in each field and link the difference to the use of the field. So field 1 is 0.5 dandelions per square centimetre. Field 2 is 1.5 dandelions per square centimetre. So field 2 has got more than field 1, so field 2 has more dandelions per square centimetre. We could put that in quantitative terms, so 3 times as many. Why? Well, who knows? They're grazing cows. Well, maybe they eat the dandelions. Maybe they poop, and the dandelions don't like that. So maybe, we don't actually know. Maybe cows eat dandelions. They might be more tasty than grass, or create conditions that inhibit dandelion growth compared to the other one. And I think that's enough of that.